Hello, testing, testing. Oh, interesting. Why is the mic picking up audio and there's no audio? Maybe it's time to close the window again. Give me a second. Oh, there, that's way better. Hello. Al Kamien 33 says, I can hear you. I could also be 4. Oh, nice. Sounds good. Leetcoding stream. Bam. How you doing today? Al Kamien, is that how you pronounce your name? Hello, hello. Let me get my Leetcoding stream up. Or the window up. Climbing stairs. Bam. Okay. Alright, it's Leetcoding time. Move these windows out of the way. Okay, so for context, we have been trying the blind 75 Leetcode questions, basically the top 75 Leetcode questions that we recommended to do before you try interviewing anywhere. So we've done all the array problems last time. Yes, checkpoint. Now we're starting the dynamic programming / recursion problems. Dynamic programming is basically recursion, but memwise, you know? Like you save each step. Or recursive call to make it more efficient. Al Kamien says, all pronunciations of my name are correct. Also, I'm good. How about you? I'm doing good too. I'm always excited at this time of the day because it's streaming time. I usually stream at the same time every day, Leetcoding, to keep my skills sharp. Okay, so we're going to do one review problem, and then we're going to do one new problem. Let's do climbing stairs first. This is the review problem. I'm going to do it in Java. Are you a coder too, Kamien? Climbing stairs. You are climbing a staircase. It takes n steps to reach the top. Each time you can either climb 1 or 2 steps. In how many distinct ways can you climb to the top? I remember this problem. We had a bit of a hard time on this last time, didn't we? Sumo paint. Let me get some sort of graphic up. But yeah, Kamien, do you code at all? Does this even make sense to you? Fortuner God says, yo, oh, it's Fortuner, hello. How's it going? What have you been up to, Fortuner? Have you been making more content? I haven't kept up with you in a while. Okay, so you're climbing a staircase, right? So let's say it's like 1, 2, 3 steps and you're starting here. Yay, that's me. So I can either take 1 step or 2 steps like that. So when I do, it reduces my problem down to n-1 for the 1 step and then n-2 for the 2 steps. And then I can probably recurse on this, right? And then every time I get to the top, that means I do a +1. If n is equal to 0, then I do a +1. Fortuner says, my PC had a heart attack yesterday. It had RAM issues. Oh no. The same PC that you can't play games on? When are you gonna get a new laptop? Laptops are expensive though, especially the good ones. Okay, so what are the base cases? I should probably just make a new function. Well, this is a recursive call, another recursive call, and then what are the base cases? N equals 0, then I return 1. N is less than 0, that means we overstepped, and we return 0. That's basically it, right? And then when you're already on the top, n equals 0, you return 1. Yeah, that's how you do it, right? And then we need to add some memoization to make it more efficient at the end. Make it O of n time, in that we only calculate each input of n into the recursive function once. Yeah. Fortune says my dad won't give me a new laptop, so I might stick with the laptop I got. Oh no, why? Why won't he get you a new one? I'm very curious what the reasoning is. Okay, let's start. Let's not do any memoization yet. Let's just do basic recursion for now. So let's do int, well, if n is equal to 0, that means we're already on the top. And then we can return 1 because that means we reached the top. That's 1. We're at the end of one path to the top, so plus 1. Else if n is less than 0, that means we overstepped. That is not a way to the top, then return 0. Fortuner says it's too expensive. Ah, I see. Yeah, laptops are expensive. Kamian says, I went to college and got my degree in game dev. Oh, cool. I wanted to go to college for game dev too, but never did anything with it. Now I'm studying for the Cisco Certified Support Technician Networking. Ooh, you're gonna be you're gonna work in IT? That's supposed to be like a pretty stable, lucrative job. Man, why'd you decide to major in game dev in college? I actually wanted to major in game dev too, because I watched a lot of PewDiePie, I think, and then there's this one video that he got sponsored by Full Sail, and I was like, wow, that looks so cool. They have programs for programming and game dev, animation. It looks so cool. My parents persuaded me not to go though, even though I wanted to go. They were like, Chet, after you graduate with a normal CS degree, you can spend your own money and go to a Full Sail if you want. And then now that I'm grown and graduated, I don't really want to go to Full Sail anymore. I have enough college for a lifetime now. Yeah. Okay, so these are the base cases. What's our recursive cases? Climb, stairs, n-1. Return, climb, stairs, n-1. Basically the number of paths. Yeah, number of paths, assuming you take 1 step, and then plus the number of paths, assuming you take 2 steps. Am I crazy? Is this it? Only one way to find out. Let's run this boy. Of course not. Cannot find symbol. It's because I can't type. Climb stairs. Hey, it worked! Let's go! Accepted. Okay, now the ugly part. When we press submit, it's probably gonna get a... No, it's for sure gonna get a time limit exceeded error because it's too slow. The algorithm. Yep, I thought so. Let's use this test case. It's 44, right? Can we kind of map out what this will break down into? Like the function will call it with 44. Holy, I suck at this. And then it's gonna break down into 43. Yeah, and then 42. Man, how does Pirate Software do it? He's so good at drawing with the mouse. And then this is gonna break down into 42. Oh, 42. And then 41. Ow, my hands. And then this is gonna break down into 41. 41. And then 40. So notice that we compute like values multiple times. Like we compute 42, 42 multiple times. We compute 41, 41 multiple times. And this is gonna exponentially spread out. We're gonna have so many open, what do you call it? I totally forgot what you call this in programming. What do you call this open space? Like another frame? Yeah, we're gonna exponentially open up so many frames to call these functions, but a lot of them are gonna be doing the same exact work because, for example, 42 is called here, and then we calculate 42 again. So we can do some memoization to make it more like... So right now this is like, what? O of n squared time, is it? No, O of 2 to the power of n, right? 0 here, 2 to the power of 1 here, 2 to the power of 2 here. Yeah, 2 of n squared time. Every time you go down one layer, it's gonna spread out the tree by 2 to the power of blah blah times. So yeah, memoization is gonna turn this into O of n time where we only calculate each value once. So we're gonna need to add some sort of hash map into this to save each result of n. Okay, Kamian says, well, I wanted to make games, saying Kamian, but once I graduated, I didn't have the discipline to continue into it. Now I work setting up different tech for companies and found some joy in working with Cisco switches, lol. Ooh, what the heck are Cisco switches? Am I able to Google images? Is this like a physical thing or like a virtual thing? Cisco switches. Oh, it's a physical thing. What does this do? Ooh, you didn't have the discipline to continue into it? Like, were you trying to be a indie game dev? Or is it just like a matter of applying to jobs? Or like you were in a job, but it was like too boring or something? Okay, let's make a helper function to do the memoization. This really tripped us last time. Public int climb stairs helper int n, and then this is going to take a hash map that maps what? The input n to its result. So hash map integer comma integer. Hurrah! Let's call this the cache because that kind of makes sense. Kamian says it allows multiple computers, phones, etc. to communicate with each other. Multiple computers, phones to communicate with each other. Oh, interesting. Can't computers communicate with each other already? Or is this like a what do you call it, a LAN thing? Connect them to each other with LAN. Oh, interesting. Why do computers need to connect to phones? Is it like a secretary use case where it's like, oh, Mr. Jones, blah 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 is on line 6. I'll switch you to line 6. Fortunate God says it's like a server. Is it like a server? Isn't a server like a little computer that when you ping it, it returns you information? Well, I guess that's like a server in that way, I guess. Multiple devices can connect to it, and then it returns, and it gets the information back that it wants, I guess. Yeah, I guess it's like a server in that way. Okay, we gotta be careful here with the memoization. This messed us up so badly last time. Okay, so we're gonna copy the recursion down here, but with a different base case now. Well, we're gonna add one more base case, so we're gonna do if cache.contains key, the current n value, then all you have to do is return cache.get the result that we've already stored. And then down here, we have to save the result before we return it, and then we save it into the cache.put n comma result, so we never compute it again. And then we do the return result. Fortunate says, lol, server 17 Pro Max. Oh wait, yeah. Kamian, is there like a such thing as these kind of tiers in switches? Are some switches just better than the others? Like, oh, this one's the premium version. This one's like the, like, I don't know. What's a bad phone? What's the brick phone called? Brick. Did I search here? Brainfuck. Brick phone. Indestruct. Nokia. Is there like the equivalent of like this switch? This switch is like a Nokia. And this switch is like the newest iPhone 15. Comment says, well, they can have better hardware. What does the better hardware do? Is it faster? Or do they support multiple connections? Or is the connection more high quality? Wait, for physical switches like this that's connected with LAN, is there even a such thing as losing information during transaction? Because it's not like you're sending packets that can be dropped, right? It's like, it's all electrical signals that are in wires. Surely you can't really drop stuff in here, right? I don't know. I don't know anything about switches. I could be totally wrong. Okay, this is the part that tripped us last time. So we have to, instead of calling climb stairs again, because that's going to create a whole new cache every time, we have to call climb stairs helper. So we use the same cache every time, and then we just pass in the cache like that, like so. And then hopefully that will save us. In Java, can I do like a little plus thing here? Probably, okay. And then up here, we're just gonna make a new cache, like this is the type of the cache. Cache is equal to new hash map. Whoop. I'm gonna let it auto type itself, and then I'm gonna pass it in. Return climb stairs helper. And plug in the cache. And then hopefully that should be it, right? No! Fortuna got banned off of Game Banana? How? No! Oh, that's actually horrible. All of your projects are there, huh? For context, Kamian, Fortuna is a game modder. He mods Baldies a lot, so this is a huge deal. All of his Baldies mods are on Game Banana. Kamian says, yeah, it allows computers to send packets to each other, and yes, they do drop them sometimes, but there are protocols to prevent that from happening. Ooh, wait, that's so interesting. How does that even work? How do LAN, like wired signals, drop packets? Like, I can understand if wired signals drop packets because it's like internet. And some protocols like, I don't know, UDP allows dropping packets as long as they get there, you know? But this is like wired. Where does the packets go? It's just buried in the corner, a little crack in the wire, and it's like, I'm just hiding here. Stuck in the crack like toe jam. Well, yeah, how does that happen? How do packets drop in wired LAN connections? That's crazy to hear. Anyways, let's run this. Wow. Wow. We got it, I think. Let's go. 100%. Second try. Was it the second try? I think it was the third try. Well, third try. Let's go. I'll take it. That is a win. Oh. Heck yes. Wait, Kamian, for your job, do they ask you to Leetcode too, or is it all just actual practical, technical stuff they ask in interviews? Wait, Fortuner, why did you get banned from Game Banana? What could you have done to get banned? That's crazy. Okay, new problem, coin change. Coin change, this is a medium problem. Oh, great. We're given an integer array coins representing an array of coins representing coins of different denominations and an integer amount representing a total amount of money. Return the fewest number of coins you need to make up that amount. If that amount of money cannot be made up by any combination of the coins, return -1. You may assume that you have an infinite number of each kind of coin. Okay, oh boy, how do we do this? I'm just gonna refresh Sumo Paint. So we have a fresh canvas. Fortune says, someone lied about me telling him to die, like, huh? Dang, what? Did you actually say anything to him? Also, he reported you to Game Banana? Really? I really don't know what to say, Fortuner. Oh my gosh. Is this one of those cases where you actually did it, but you just didn't mean to? Like that last time? Or are you completely innocent in this case? I really don't know what to say. Fortunate says, I didn't tell him anything. Really? You never talked to them before? Like ever? So you've never talked to him before? Okay, you are given an integer array coins. How the heck do we do this? Kamian says, oh, she's talking about the, or I mean, he, I don't know what your gender is. He or she is talking about the switch dropping packets. Basically, computer A first sends a request looking for the MAC address associated with computer B. Then B sends a response that the MAC address belongs to them. And finally, A sends a response back that they got it. This forms a connection between two computers and they both remembered who the MAC address belongs to. Oh, okay. Fortune says it was Thumbly, the same guy who talked behind my back. So you have talked to him before. The guy who you sent weird memes to, that guy. Man, Fortuner. Are you sure you didn't tell him weird things, but you were just in a really bad state? Are you sure? Kamian says, oh, you want to know how they drop packets, eh? Said in Marcus' voice. I don't know who Marcus is. Who's Marcus? Yes, tell me how they drop packets, please. Okay, let's say the list contains... Dang it, Fortuner, what did you do this time? Fortuner is such a funny dude. Fortuner says, I swear on everything that I didn't tell him anything. You've never communicated with him before? You didn't tell him anything? Oh my gosh, Fortuner. Why are you so funny? Okay, let's say we have a 25, a 10, and a 5. Oh, from Borderlands? Yeah, I've never played Borderlands. Can I look up what Marcus is like in Borderlands? Borderlands. Marcus? Am I gonna get demonetized because of music? Yeah, I better not risk it, actually. I'm not gonna do it. Fortune says, like we talked, but I didn't tell him to, or anything. Do the intro? Marcus. Borderlands intro. Fortune says, so I kicked him? Okay. Well, if you didn't do anything, you should be able to appeal this, right? With proof.
So, you want to hear a story, huh?
Oh, he said the thing. So, he got mad and lied? Okay, that's good on you then. Well, I hope you can get your Game Banana page back. Nice, we saw Marcus's voice, we heard his voice, and we didn't get demonetized, yay! Huh. Okay, return the fewest number of coins that you need to make up that amount. How in the frick do we do this? So we have... What information did they even give us? The coins and the amount. Let's say our amount is like... Let's say the base case is like 0, right? But we also need to store something else, which is... Do we actually need to store the amount of coins we've used? Huh. Or did we take care of that in the return statement? Okay. Oh my gosh. Writing with the mouse is so hard. And I misspell. Okay, let's say the amount equals 0, right? That's our base case. That means we can just return... the fewest number of coins. So return 0? 0? Because we need 0 coins to add to 0. Is that it? Otherwise, for each coin... Fortuner says, okay, I got my account back, but I can't comment on anyone's pages on Game Banana. Oh, that's good. I'm glad you got your account back. For each coin. Oh, I'm just gonna draw a coin. I don't wanna... There's a person on it there. For each coin, you would do 1 plus your current amount minus the coin value. Is that what we do? And then... Oh, and then if the amount is less than 0, then we return like some bogus value, right? Like -1. And then if we see a -1, then we know don't use that value, I guess. Tyler Clip says, yo, I'm new, I'm wondering what y'all are doing. Oh, we're doing coding interview questions, specifically recursion. I'm a professional Leetcoder, well, self-proclaimed professional Leetcoder. Whoop, I accidentally hit the mic. We're trying actual coding interview questions asked by real tech companies. Yeah, that's what we're doing. So this one is called coin change. You're given a list of coins and the amount that you're trying to add to. And you're trying to see how many ways you can add up to that amount. That's basically it. Tyler Clip says, what languages do you know? I'm currently typing in Java. At work, I use TypeScript and Python, but I'm not good at those languages because I basically just vibe code with those languages. Yeah. Yeah, how about you? What languages do you know, Tyler? Do you also code? Sounds like you know a bit of coding too. Okay. Tyler says, I'm scared of Java. No, why are you scared of Java? Anyways, my current strategy for coin change is... Okay, my current base case is, because this is a recursive problem, right? My current hunch is that our base case is amount equals 0, because then that's... You basically are already there, right? You don't need any more coins to add up to the solution. In this case, you return 0. And then else, for each type of coin, you do 1 plus and a recursive call to the current amount minus the coin. But we kind of got to be careful here, because what if the coin just doesn't work, right? What if we, I don't know, it makes the value negative? We have to watch out for that too. In this case, we might have to add to -1, or like return -1 for the base case. And then we have to detect if it's like -1, so to make sure we don't add to it, you know? And oh my gosh, too much people in chat. What are they saying? There's... Wait, the... There's so many people typing in chat now, I can't read everything. Oh no. Maybe I can read in my YouTube browser. Why not learn Python? Oh, because... my first ever job was in Java, so I'm more proficient in Java than any other language right now, so that's what I choose to lead code in. But yeah, I do hear that Python is more optimal for lead coding, because you can type very few lines of code and then get a lot out of it. So yeah, I do actually recommend Python if you're new to lead coding. Code Kill said, "Hey, I just saw your stream and dropped by. I love the vibe you're bringing to solving LeetCode problems. I've also started a 45 days of code challenge on my channel." Ooh, good luck on that, man. Would be great if you could check it out sometime. Keep up the awesome energy. Thanks. Tyler says, "Shall I write this in Python?" Sure. You want to do it with me? You could totally do it with me. And then Fortune says, "Check Discord." Ooh, Discord? I don't really have time to check Discord right now. Maybe after the stream. Okay, back to this problem. What I'm thinking right now is, if the amount is equal to 0, then what do? You return 0, because you need 0 coins now to add up to your target. Wait, I just realized we might need to take the min of all of these, right? Do like a giant min, because our goal is to return the minimum number of coins it takes to add to our target. So we try out every denomination and then we take the min of all the answers. Yeah, that's what we do. And then I'm still not sure about this, but I think if amount is less than... Did I just spell amount wrong? I think I did. If amount is less than 0, then let's return -1 for now. We can check for -1 as a specific bogus value, so yeah. And then else, this is the recursive call for for int coin in coins. I forgot, is this how you do a for each loop in Java? Let's do a sanity check first. Coin plus the current coin. Wow. Oh. Return -1s as a bogus value first. Submit that boy. These are just passing. Okay, that's wrong that it's passing, but alright. So coin 125, 125. Okay, so this is how you do a for each loop. So for each coin, we have to do a recursive call. So we do coin change. Let's call this int result is equal to coin change. And then what do? We have the same number of coins, right? We just pass it back in. And then the amount minus the coin denomination. We need to track our current min, right? So int the min Wait, what is the question asking again? The fewest number of coins that you need to make up the amount. So min coins is equal to, let's set this to just integer dot oh sorry, I have not been reading chat. I've been too consumed with this problem. Tyler says, do you earn money coding or maybe from your job? I'm trying to start earning money, so yeah, any advice would be dope. Oh, PogChamp Senpai, hello. Hi PogChamp Senpai. Welcome back to the stream. Yeah, I do earn money from coding. I'm a actual working software engineer. Do I have any advice for coding? I mean, it highly depends on where you live, right? So I can only give US specific advice. So some advice are, do lots of Leetcoding problems because how the coding interviews are basically going to go is that they're going to give you Leetcode problem after Leetcode problem, and then you're going to have to solve them and try to get as close as you can to 100% because they'll have any reason to drop you or not let you pass in that interview. If you're trying to go for more higher level roles, or maybe even in some entry level roles too, they're going to ask you system design questions. I recommend this book called Alex Shu, System Design. Yeah, this book, System Design Interview, An Insider's Guide. I read this book while I was studying for interviews. So system design is basically how do you design an app? Like for example, they're going to ask you, how do you design YouTube? Like what's the configuration of servers? What are the data structures that I need? What type of servers do I need? Like, do I use cloud queues? Do I just have like a process running continuously in a server that eats in the cloud queue and it does stuff with it, you know? And then how do I optimize my app? Stuff like that. Yeah, I'm not too great at system design either. But yeah, I continually try to Leetcode so I can brush up my skills, keep them sharp for interviews. Okay, what do we do here? So if result is not equal to -1, meaning there's actually a solution, then min coins is equal to map.min, the current min number of coins, and 1 plus my result, because I have to use 1 coin. You know, the current coin that I spent. So this is max value, I think. And then in the end, I return min coins. I don't have high hopes for this. Let me just run and see what happens. Oh, okay. Min coins is equal to integer.max value. Oh. Oh. Hold on. Math.min. Why are we going to the negatives? Well, this is probably the culprit, right? Min coins is equal to -1. Maybe if I just set that to the start condition. Okay. Expected 3. Output is -1. Oh, great. Time to debug some recursion. Very fun. So these ones are right? Oh, okay. These ones don't mean anything. Because they're just 1. -1. 0. Okay, so my base case is right. Amount is 0. So my output for this is -1. 3. Hmm. Hmm. Oh boy. How do I even debug this? How do I debug recursive problems? I can print out a lot of stuff, but it might get kind of confusing. You know what? That might be my only choice here. Sure, let's print out stuff. Let's do system.out.println trying coin. Let's do the coin there. I'm kind of conflicted. Printing stuff out while trying recursive stuff is always... It can be either very hit or miss. Can I try reasoning through it first before I try printing stuff out? So, if the amount is equal to 0, then we return 0 because we need 0 coins to add to it. If the amount is less than 0, can I return actually like integer dot max value so that, you know, it gets the value way up high and then... Wait, this is gonna do an integer overflow, isn't it? If we try adding 1 to this... Oh, okay. Maybe -1 is the right way to go. And then min coins is equal to -1. Oh wait. I think we should do a integer dot max value here. Because if I have like, I don't know, like a 2, -1 is less than 2, so it'll think the answer is -1. Ah, okay. And then down here, if the min coins is equal to integer dot max value, like we have no solution, like everything is just no solution, then we return -1, right? Else we return min coins. Ah, I feel like that's the fix, right? Int cannot be converted to boolean. Oh, it's double equal sign. Let's go, we did it! We did it, boys. See, we just had to reason it out. No need to print stuff out. Okay, when I press submit, it's probably gonna get like a time limit exceeded error because we need to do some memoization, which is always a pain. Yeah, time limit exceeded. Let's use this test case. So we can totally use a hash map again to sort of cache our intermediate results. So it's just O of n time, hopefully. We need to calculate every value from 0 to n, 0 to amount just once, instead of exponentially branching out and calculating every single frame. Okay, let's try this. We gotta be careful here. So our helper function is going to be the one doing the brunt of the work. Let's call this coin change helper, and it's going to take in a hash map of integer comma integer. Fortuner says, well, I gotta go now. See ya. See ya. Thanks for stopping by. This will be the cache. Okay, and then we gotta add a new base case. So if... Let me put the problem back up again to... Yeah. Okay, new base case. So if the cache dot contains key, the current amount, then we just return the cache value. return cache dot get amount. Yes. And then over here, we need to save our result first in a variable, add it into the cache, and then we return it. So int result is equal to, let's say, -1 by default. And then if min coins is not equal to the max value, then the result is equal to min coins. That makes sense, right? Result is -1 by default. If the min number of coins is equal to max value, that means we do not find any solution. Then result equals min coins. Yeah, okay, that makes sense. And then we return the result. We also have to add into the cache before we return it. So cache dot put, is it put amount, comma, result. Okay, let's try running this. Wait, this does not work. Hold on. I wish I can stop it, but I can't. Yep, time limit still exceeded. Yay. So we need to change this to a recursive call too. So we'll put this as coin change helper, the coins, amount minus coin, and then we'll put in the cache here again. That should be the only recursive call we made, right? And then up here, we're gonna have to do the actual setup of the cache. This is the type of the cache. Cache is equal to new hash map. And then we return coin change helper, the coins, the same amount, and the cache. Fingers crossed. Is this gonna work? Place your bets, boys. Of course it doesn't. Cannot find symbol. Because capitalization. Let's go, it worked. I is a genius. It worked, let's go. Just barely though. It's so slow. Why is it so slow? Can I see what other people did? They probably did some bottom-up thing, didn't they? Can I try submitting again? Is it because the hash map is like really slow? Coins.length is less than or equal to 12. Alright. Oh wait, it's 12 a.m. I think I will... Well, I mean, I solved the question. Maybe next time I'll try to figure out why it's so slow. Actually, I can just figure out right now. So what they did is they have an array to store the min coins for each amount from 0 to amount. Oh dang, that's a huge array. Initialize the Crimson Moon says Crimson Moon? Wait, are you the same person? You code too? Wait, let me double check your Discord username. Crimson Moon? Are you the person who drew me that really nice picture? Yes? Wait, you code too? How can one person be good at two things at once? I was like, wait, you code too? What? I tried this problem, I was able to do it using dynamic programming. Ooh. Very nice. I did it with recursion, but with some memoization. Yeah. Oh yeah, thanks for the artwork, by the way. I used it in a post and also multiple thumbnails. I did credit you in the description, so yeah, thanks for the picture. I really like it. So what are they doing here? They're using an array that stores 1 through the amount, the target amount. Array.fill. Initialize the DP array with a large number, amount plus 1. Okay. So I guess it's easy to take the min. Wait, that's so cool. You draw and you code at the same time. Are you studying to become some sort of, I don't know, engineer or something? Base case, no coins needed to make amount 0. Crimson says, dude, that art was not mine, lol. I am another guy with same username. I see. Dang it, miscommunication. Oh wait, the other person was called Moon Skyrunner. Dang it, I remember the name wrong. Okay, well, hello. Welcome to the stream. For each coin, we need to update the DP array. For each coin, coins. Okay. Int I is equal to coin, while I is less than the amount I plus plus. If we can make the amount I by adding the current coin, dpi is equal to math.min dpi, comma, dpi minus coin. Oh, plus 1. Oh, I think I'm seeing this. Oh, dynamic programming has never been my strong suit, but basically it's saying the current amount, what's the min number of coins I can use to add to it. So for each coin, you basically subtract it from the amount, meaning you've kind of used the coin already, and then you add 1. And then hopefully the array for this amount stores already the min number of coins you need for that amount. So you just plus 1, which is the current coin. So you take the min of, either the min coins that you've determined for this current amount, or the amount after you've used a certain coin plus the coin that you used. And then you return dp amount, which stores a solution. If it's equal to amount plus 1, which is the original value, then you return -1. Else you return dp amount. I see. Yeah, okay. I guess that makes sense. So dp0 would be 0. For each coin, why do you start with I equals coin? Oh, because you can't possibly, for example, if the coin is 25, it's kind of meaningless to say 24. Can I add up to 24 using the coin, I see, okay. So let's say you have a 25, right? dp0 is just 0. dp25. Wait, what will we do for dp25? So you would do dp25. So the amount will be 25, minus 25 is 0, and then you would check 0, which is 0, plus 1, which is the 25 cent that you used. Crimson says, I tried again in recursion, it still gives me teary eyes. Oh, it still gives you time limit exceeded? Yeah, I tried using recursion. I had to do some memoization tricks. Yeah, so this is my recursive algorithm. This is my hash map. Okay, I'm wondering... This is basically the same thing, right? I would start to hit results at the lower numbers, right? And then I would start caching them. Like I would go write down a single branch. Yeah, right? So is it the hash map that's kind of slowing me down? Probably. I feel like my solution is basically the same, is it? Except I'm going top down instead of bottom up. Maybe next time I can try, instead of using a hash map, using an array whenever possible. You know what? I can totally try that now. Crimson says, yeah, similar. Yeah, it should be similar runtime, right? I only calculate every single amount once. Because after I calculate it once, it's cached. Let's do int cache is equal to new int array with the size of amount. So 0 to amount. Do we do amount plus 1 because off by 1? If amount is 1, it's going to just have index 0. Yeah, amount plus 1. And then in coin change helper, we're going to just pass in int cache. And should we... Yeah, we got to instantiate with something, right? If arrays.fill the cache with maybe -1. Is that how you do arrays.fill? Yeah, it is. So if actually I already have -1 here. Should I do a different value like -2? That's the key. That's the symbol for cache hit. If cache amount is not equal to -2, then you return cache amount. Crimson says, I think recursion will always give time limit exceeded because it recalculates the same subproblems multiple times. That is true if you don't use memoization, but if you cache or memoize all of your intermediate results, you should not get time limit exceeded. Like this one, this is done with recursion. Return cache amount. If result is -1, okay. So you put it in the cache here. Cache amount is equal to result. Okay, let's run this. Hopefully I did everything right. No. Index -1 out of bounds. Why are we looking at -1? Oh. This amount needs to go higher. This check. If amount is less than 1, return -1. Crimson says, let me try. Yeah, let me know what happens. Hey, we got it! Submit that boy. Wow, see? Okay, the hash map was dragging me down. It's now up to 30%. Okay. I feel like this solution is really messy. I don't like the use of -1 and -2. Is the use of -2 okay here? I don't want to do -1 because it might conflict with this. Wait, do we even store the result if it's -1? We don't, right? Because automatically if you call it, it's just going to return immediately. So we probably could do like -1, -1, -1. Run it. The use of -2 is so weird to me. Okay, yeah, we can use -1 as a bogus value here. What? Return cache amount. Okay, I don't know what happened. I'm gonna just backtrack and then put this back to -2. Okay, we're back to 30%. I am done for today. I'm done. Okay, thank you to everyone for coming. Thank you, Crimson. Thank you to everyone else in chat. Who else came today? Fortuner, PogChamp, Tyler, CodeCules. Yeah, I appreciate it. I'll see y'all next time. Bye.